Miles, thank you very much. Welcome, everyone. I will take the first part of this webinar and then turn things over to Greg. And so here we are, the new AIAG VDA FMEA. So let's go right to the agenda. Bear with me, folks. All right. So what we'll do is we'll cover the background to the new AIAG VDA FMEA, then go right to an introduction to how this new, AIAG VDA FMEA, we'll call it a form, but we'll explain more as we do that. Then Greg will come on and talk to you about the six-step process, the DFMEA in action, and you do see the PFMEA in action in yellow because by the time we got done describing the DFMEA, we just were plumb out of time. So what we're going to do is we are planning to do 3 webinars on the new FMEA. The next one will be on the new AIAG VDA PFMEA, and then we'll do a higher level analysis, benefits and conclusions in a 3rd webinar. All right, but we will do a summary of the presentation, conclusions and recommendations, and as time allows, we will do a panel discussion. All right then, so what is the background to this AIAG VDA FMEA? I'm assuming many of you knew about this, that there was a task force formed to combine the VDA and AIAG FMEAs. And there was a project put into place. Why? Well, in the end of the day, plain and simple, there were differences in both the methodologies. Greg and I, with our counterparts in Germany, from our, we have several different consultants, Omnex consultants who specialize in the VDA approach. We had met several times and discussing the differences and the benefits and the problems with both the approaches prior to this task force being formed. So, we very much think it's timely that indeed such an endeavor was put into place. The team members of this project were OEMs and Tier 1s. Timing, well, this is you can see that if you don't know, the first edition draft has been released. There's a 90-day commenting period, and the idea is that sometime in March, maybe early April, that there will be a release of this standard. And again, as we talk about the new FMEA, we have to say, that it's not required for your IATF 16949 registration right now. So please relax. This is something that's going to take some time. And Greg, if you can unmute yourself, I'd like you to just comment about this task force. This is not the same task force as the original IATF task force, if I'm not mistaken.
Yes, Chad, you're right. The original blue books were sanctioned by the Supplier Requirements Task Force, or IATF, as it's now known, which is a superset of that. This one was actually, the standing was actually AIAG together with the reason why the copyright is that the blue books for copyright.
Hey, Greg, we're having difficulty hearing you. I'll just give you a heads up. And I'm just going to go on because you're coming in and out. So let's get that fixed, okay? So folks, this is the view of the new AIAG VDA FMEA, first edition. Well, what is the first look? We can say, yep, it's long. It's a long form. So beyond that, you may notice different colors. And the different colors, till you get to the optimization step, is in threes. So why do we have it in threes? Let's try to understand shortly. But before that, let's compare the fourth edition and the first edition. We have the item. What do we have now? This item now is broken. Actually, you can think of it as three items, but still the focus element, we call it the focus element, is the one in the middle. And then we say on the left-hand side is a higher level element, and to the right-hand side is a lower level element. Now I have to say, if you're going to do a bill of materials, that is 4, 5, 6 deep, the system may not always be on the left. The focus element may not, and then it may not be a component on the right, because you may be anywhere in your analysis. All right, I've confused you already, I know, but you're going to have to get used to it, that now we're talking about an element, a higher level element, and a lower level element, okay? You want to think of it as the BOM. All right. Next, what do we have? Well, we used to do functions and requirements of the focus element, or the item, as we called it. Now, you're going to do a function and requirement of the higher level element, or the system, as we're calling it here, the focus element, the one in the middle, and then the lower level element called the component in here, but as I said, it may not be a component. Anyway, you do functions and requirements of all three in terms of the higher and the lower and the one you're focusing on. All right, what happens next? You identify the failure mode of the focus element. It's actually the failure mode of the higher level element. It's the effect. And the failure mode of the lower level element is the cause. So the idea is that when the component fails, the item we're looking at fails, and it causes a failure in the system, okay? The effect is a failure. So again, you see it in threes, and then what do? You identify the current design controls and for prevention, and you do the current design controls for detection. All right. So sorry, so that part of it is fairly the same, but there's no RPN anymore. What we do see is an action priority, or AP. All right. And I'll just say this: the current detection and the current prevention is a little bit more complicated, because you'll have to decide, which is it for the component, or is it for the item we're focusing in on? All right. Next, we have an optimization step. The optimization step is fairly similar, but they've broken prevention and detection from the recommended action. And then they also have a status, and we have the objective evidence. We have Jorge Correa from Intertech, and we have Rod Gray from Flextronics, who are going to be part of a panel discussion. And I'll just point that out to both of them, that the evidence of the action taken with the pointer to the evidence will be there by the new FMEA. All right. So I've spent already probably a little too much time. And by the way, Greg, feel free to comment anytime as I go through this. Now, the last part of my introduction is going to be how things work today. How do things work today in our current methodology? Well, we have an item and a function. That's what we call the focus element. We identify the failure mode. Well, first we say what are the functions and requirements. Then we say what can go wrong, which is the failure mode. We ask what are the causes. And once we come up with the prevention for the causes, we can come up with the occurrence. Okay? And then we ask the question, how can this be detected? And we come up with the detection number. And then we say, what is the effect of this on the customers? Remember, everything higher is called customer, including the assembly line, the next process, and so on. And from there, we get the severity. This is the way the current FMEA works. Well, how does the new FMEA work? Sorry, I should have kept going here. Then we have an RPN number, and then we come up with recommended actions. And that is the way the current FMEA works. What about the new FMEA? Again, the new FMEA, so that we have the focal element, the one in the middle. It has functions and requirements. So we're going to in the function analysis, we're going to the function and requirement, again in the middle. And then it has failure modes. Again, functions and requirements. Once you have a requirement, the negation of it will give you a failure mode. All right? All right. Next, what do you have? You have the higher level element, and it has functions and requirements, and it has failure modes. And then you have the lower level element. It has functions and requirements, and it has failure modes. This is the way the new FMEA is put together. And you'll have to think now a little bit to understand it's actually three-dimensional. It's not flat file because there could be many effects, many causes, and for one failure mode, which then it's not very easy to show that in a flat file. In fact, even in this presentation, as we explain the six-step process that Greg is going to take over now, as we do it, we're going to share with you a case study, and we're going to show it's a airbag. We're going to show it to you using software to be better able to explain how to do it. Oh, okay. I have one last slide. And the last slide just says, look, there are 6 steps in this process. There's a scope definition called the 5 T's. Greg will explain. Then there's a system analysis where functions and requirements are done for the focal element, the higher level element, and the lower level element. Structure analysis first, which is just explosion of the bomb, showing the entire structure of the entire product. That's the second step, pardon me. In the third step, you have, for the 3 items you're looking at, the items that you're focusing on, the higher one and the lower one, the functions and requirements. And then you have the failure analysis. Here, I will just point out. And it's that when you do the failure analysis, again, is a negation. It's in 3s of the requirements of the functions, okay? And the idea is a failure mode has so let me start like this. At a lower level, failure causes a failure in the focal element, and then there's a failure of that in the higher element. So there's this relationship between all 3 failures. And then you have current prevention, current detection, and then you have optimization. Let me just go through this because I'm eager for Greg to continue with this webinar, and I'll come in between and share with you the case study. Go ahead, Greg.
Thank you, Chad. Hopefully you're hearing me better now than previously. The general approach or philosophy for the FMEA is the same for the previous editions and this now the first edition of the AIAG VDA. One of the differences that the current new FMEA has a more structured approach. It does have additional tools or display graphics on there. And as Chad said, you have to have a minimum of 3 levels in order to be able to do the FMEA. The new FMEA was developed so that it could be used with a spreadsheet, recognizing that most of the suppliers out there are using Excel-based FMEA activities. However, even the handbook recognizes that if you start getting into more complex products, you're going to probably have to use some kind of software to do it. The elements of the steps for this is pretty much the same as before. You start off with the scope. The scope has actually been in there from the very beginning. It was the 4th edition, started bringing it up to the forefront, saying that you have these certain prerequisites, one of which is to define what is part of the project and what is not. The structure analysis, because we're doing things in terms of 3 levels each, we have to know what is the relationship between each of those, which kind of puts additional requirements on the team, because they have to be concerned or looked at the focused element, the one that's the product they were working on. Yes, they did have to understand what it was going to be used for, and they did have to understand the components, but they just necessarily were looking only at the focused element. In the past few years, there has been an expansion, even with the 4th edition, with systems FMEA, which is in line with the overall structured approach. Now, if I'm going to have a structure, I need to put in additional information. As Chad said, with the 3 levels, you need to do a function analysis, which was always there, but now we do it at all 3 levels, a minimum of 3 levels, as well as the failure analysis. Once I have the function and requirements, I have to ask the question, what can go wrong? And then I do that, and the failure analysis actually encompasses, because I'm looking at the 3 levels, it's actually encompassing not only the failure mode of the focused element, but it also encompasses the effect of that failure by the higher level failure mode, and it encompasses the causes by looking at the lower failure mode of the lower level failure modes. This can be restrictive if your causes are not directly related to a particular lower level component, but there are ways around that. Once we get that information, then the risk analysis is essentially how much standpoint to a detective standpoint, and then coming up with actions priority. As Chad said, RPN has been dropped as a major requirement. You can still use it, but instead they have an alternate approach, which is the action priority tables, and we'll show you what that looks like. And then finally, the recommended actions, which are now called optimization. How do I improve my product as I'm going through? So that when I'm putting it into an Excel file, I get my design FMEA form complete. Next slide, please.
Yeah. So, folks, as I proceed to the next slide, I'll just mention, if you may or may not know, Greg was on the writing committee of the 4th edition and the 3rd edition FMEAs. And one thing, both the process FMEA and the design FMEA have the same 6 steps. Go ahead, Greg.
Yeah, the application is a little bit different in the design FMEA when we're looking at the scope. As before, we do have the block diagram is the major tool that is used. One of the things that has been introduced in the new FMEA is to document some of the background of why you're doing what you're doing. The team has always been there. The timing has always been part of the header information. The intent tasks and what tools are going to be used is needs to be quantified now and documented. Okay, next slide. So the 5 T's, as it's called, is the team, timing, intent, and yeah, they get that 4th T by looking at the 3rd letter of the word intent, and then finally tasks, as opposed to 2 T's, I, and T. It's called 5 T's. The aspects of that is to provide include what is included and excluded in the FMEA. So you can look at it as being part of the project plan, and it does put in some boundaries, if nothing else, from a physical standpoint of the people involved. Okay, next slide. The block diagram has been used in the past, and it is continued to be used. Also, you may be familiar with, and it's been included in the 4th edition, the interface matrix and parameter diagram to provide us more detail. This new thing that is in, and it's actually put in its own step, is the structured analysis, which is in a tree structure. That is the defining how the parts go together. And as Chad mentioned, it's actually the BOM where you're looking at from the different levels, the overall product and the first layer, second layer, and so forth. The parameter diagram is used as in the past to provide us with additional information. So we want to know what is included and what is not included. Okay, next slide. This is a sample of a block diagram. The dotted lines show what is included in the analysis, but it also shows interface and interaction. In this particular case, we have the speed sensor and the ABS information is being provided to this particular product, but it's the ABS and the speed sensor in it is definitely not part of the airbag system analysis. And then you also have vehicle power, which is outside the scope. Now, these can become very detailed, very involved. You could include things like environmental and other products that could interface, as well as nowadays with the fact that one particular product can be providing supporting information or support from a safety mechanism standpoint to others. This could also be shown in here, but essentially it's to try to understand what are we going to be talking about. All right, next slide. The P diagram is it's called parameter diagram. It's trying to take a look at the parameter. My ideal system or my ideal product, it would be just looking at the input, the system, and the output. But we unfortunately do not have ideal systems. We have things that we can modify in the system. Those are the control factors. Those are things that the design engineer has direct control over, can specify, and so forth. But there's also noise factors. These are things that could affect the output, but we don't have control over. Things like changes in time, customer usage, and so forth. It's up to the engineer to use the control factors to make the product robust to these noise factors. And so there's a lot of emphasis nowadays also in looking at the robustness of your product. hit the key again because we got one more piece. Okay, with those noise vectors, we also have the error states, which are really the failure modes of the product itself. This is an example. This is actually from the 4th edition of the FMEA manual. It shows a catalytic converter where we have the input, we have the converter itself, and then we have the output. Here we have the noise factors, things that could affect the product, and then what is it that the engineer is going to be using to design the catalytic converter. The error states in that are, we would expect to see those reflected as failure modes of the requirements, responses of the product itself. All right, next slide.
Great. So, Greg, what we'll do now is we're going to have a running case study of the airbag system, and you'll actually see sort of the airbag in its preliminary architecture block diagram. What you saw so here it is. We're picking the block diagram. Here's a block diagram, and it's a preliminary architecture, and here's the bomb we're seeing there. And you click the bomb and say, it's part of the block diagram. Suddenly these elements show up out of scope, and then you can draw whatever connectors you want, whatever color you want. Now, important here in the block diagram, I'll just go back here. In the block diagram is the idea, bear with me one second, is the idea of the interface functions. So when you draw this as a block diagram, you can actually automate the interface functions and say speed sensor to ECU interface function, front cache sensor to ECU interface function. So those actually will get populated automatically into the DFMEA. Then also, as soon as you finish the block diagram, you can go directly into the P diagram, which will have the pasted in there, and then you can fill out the different error states. Think of this as sort of the setting up of this case study as we go and do the structure analysis next. Go ahead, Greg.
Okay, the structure analysis is really a graphical, well, you can use, and in complex problems, it would probably be best to use some type of graphical interface. But really, it's trying to show what is the cascading, what is the flow down, what products are at each particular level. So we can look at the structures that we start off with the system, and then our particular case, we have the airbag subsystem, and then there are products within the airbag subsystem, which is the airbag controls activities, and then we have the component, one of the components of that would be sensors, the internal sensor that's under our scope. So we want to get an overview of the system structure, where is what. And one of the advantages of this is that in the past, some design engineers, when they started doing an FMEA, they immediately jumped down to the component part without looking at what is the cascading of those requirements. And so they started mixing and matching. So this is one thing that would assist in ameliorating that exercise to do that. We definitely would have the definition of the system's boundary and interface. And once we do this, we can, if we have it done properly, we can assist in the reuse of the different elements at different stages. All right, next slide.
So here's an example, Greg. Go ahead.
Yes, this is a very simple tree structure, and so you will see often these things used. Do you have to do a tree structure? No, you can just do this directly in the FMEA, new FMEA form. You do have to be careful when you do that from a spacing standpoint. All right, next slide.
All right, Greg, I want to make one point here.
Yeah.
That
all right.
This is sort of the thought coming from VDA that the world is in 3 levels. And there's a system, and then there's a component, and then there's a product. Of course, you know, things are way more complicated than that, as we'll show you just in the airbag itself. Here's a throttle positioner. Go ahead, Greg.
Right, which the throttle positioner actually is a subsystem of the electronic control unit to accelerator control unit. So throttle positioner is one of those components or one of the subsystems that you do have in the electronic acceleration system. But even there now you have the 3 levels. So you go from the throttle, then you have all the components that go into the throttle positioner, and then you have each of those components could have individual parts. So eventually you come down to a dead end at the parts level. A part is something that cannot be divided further into subparts. So we get those. All right, next slide.
Great. Greg, one point I want to make is that when you do the system structure, you have to decide, are you going to focus on the servo motor, transmission, throttle assembly, and then that becomes your focus element, all right? Then what's on the left, the throttle positioner becomes a higher level, and everything to the right, for example, in the transmission, will be the primary gear axis, and secondary gear become the lower level elements. So the lower level elements don't have to just be 1, but the focus element is only 1.
Yeah, by definition. Right.
Great. So I'll just go here, continue with our example, where we pick from the structure analysis. You see here the front impact airbag. The front impact airbag has a speed sensor and vehicle power sensor, and it breaks down to 2 passenger airbag, driver airbag, and let me just pause that for a second. And all those different components, and then the airbags have initiators. So keep that in mind. In this example that we're going to talk to you about, continue, I forget now whether we're focusing on I think we're focusing on the driver airbag, and here the lower level element is only 1 initiator, and the higher level element is a front impact airbag system.
Yeah, one of the things that some people initially looking at this say, well, what about this speed sensor? Isn't the speed sensor part of the frontal impact airbag? Well, you have to remember, looking at the block diagram, that we did have an out-of-scope element, which was the speed sensor in the ABS system. So that's the reason why that is separated and not included in the level of the lower level of the frontal impact airbag system. Go ahead. Okay, once we've got the structure, that just kind of gives us all the physical parts on how they go together. We now need to know, well, what is it supposed to do? The functional analysis, what are the functions and requirements for each of the levels themselves? And this is the same thing as in the past. What should the product service be doing? What are the functional deliverables? Looking at the different requirements and under different conditions. All right, go ahead. Now, when we do this, obviously, we're looking at all the different customers. Requirements, and the handbook does bundle the functions and requirements together, but this comes to us from the 4th edition that if you're going to be doing failure modes, it is more efficient to look at the details of those functions. How can I determine a failure mode if I don't know what the function is supposed to do? So the requirements are the measurables. What am I going to be, what do I expect if this function is doing what it's supposed to be doing. And consequently, you want each requirement separately. Systems engineering talks about atomic requirements. Each requirement has to be standalone on its own. And so they should be described as a noun, verb, measurable format, and so forth. Okay, next slide.
Greg, I want to make a couple of points here. One is,
sure,
going back to the P diagram, you know, the idea that the P diagram will help you identify the requirements. And number two, what I want to say is, you know, we're melting together two approaches, and the examples given in the manual go through a lot of, you know, like we did in 26262, Greg, in terms of partial function, full function. You don't have to go through that kind of analysis against functions if you actually define the requirements. And we'll just say this, the new FMEA does talk about requirements. We absolutely believe functions and requirements are needed before you can come up with good failure modes. Do you want to comment on that, Greg?
No, I agree. I concur with that, that if you don't have the requirements, if you're just brainstorming failure modes, you can get most of them on there, but you may miss some because you don't have the specifics involved with what is that function supposed to do.
And my thought on that, Greg, actually, we'll do that in the third webinar, that you might just come up with a lot of functions, a lot of failure modes that may not happen where you can be very specific and dead on if you have the requirements. Go ahead, Greg.
Okay. Now, one of the things on now, obviously, if we have this on make a list, we could have a list of all for each level, all the functions each of the level does, and we can put in requirements. Unfortunately, that doesn't really help us fully because one function does not require all the functions of the focused level or the bottom level. So what we really are looking at is, in this particular case, a flow down of requirements. And that's another thing that Chad mentioned, 26262, they actually make that mandatory that we have a traceability of the flow down of requirements, and it's actually a very good best-in-class approach on doing it. So if I want at the system level, I want the car to be safe, but what does that mean when I'm talking about the airbag systems, and what does that mean? How do I get that? What is the function of the airbag in order to do to the system? And so in our particular case, in order to protect the passengers, we have to deploy on demand. And then we go down to the sensor level. And so what does that mean from the sensor? In order for the airbag to do its job, the sensor has to activate or identify when there is a collision. So we are, when we're doing something like this, we do definitely need the flow down of information. Now, Chad added a comment here: should the function analysis be only for 3 levels of production or conducted for the entire product structure at one time? And I guess the answer is that depends how complex there is. You need, based upon the new FMEA, you need to do it for at least the 3 levels. However, that may not give you enough information at the very end because the bottom level may have more complexity afterwards, and so it may behoove us to go further on down through the system. So you could have multiple, do this analysis for multiple levels. Do you have any comment on that, Chad?
No, I mean, it's just that we should not, I mean, I don't, you know, when we look at this methodology, let's make sure you understand it's the entire system, right? And it's, you know, and don't artificially confine yourself into 3, especially if you're the owner of the system. Right.
Oh, definitely, yes, yeah. So the goals of function on...
Go ahead. Greg, we're a little bit behind, so I'm just trying to move us forward a little faster.
All right. Probably the key thing, as in the others, once you have your functional requirements, then you can get the failure analysis, because once the requirements are there, we can easily get into the failure. All right, go ahead.
So the key in this whole step is the function analysis and the ability to do the function analysis because of the complexity of doing something like that. So you can see here from the front impact airbag, we're able to, in fact, the example shows, let me just go back, that you're able to see it in a table structure or in a list, so it can easily identify the functions and requirements with the F and R. And then what you do is you'll see the opening up of the driver airbag and then dragging and dropping a function and requirement. Hang on, there they do it. And then going back and identifying the initiator, which is, you can see there, and then dragging and dropping that. And in this way, building, and you can keep on building it into multiple levels if you want, or you can stop at 3. The idea, very important step of identifying what functions and requirements, we call this sort of a flow down step of functions and requirements down the structure of the BOM.
Okay, once we have the relationship between the different functions and requirements, then we can now go and ask the question, what can go wrong? So we go into the failure analysis, which is in the form, it's the next 3 columns over, and so we got to do the jumping. Go ahead. So we want to, for every requirement, we want to identify potential design related failure modes, the logic of we have to assume that the production is going to make the product the way it was specified. So we're looking at why would the design fail when it's built as specified. Go ahead. So we have that same flow down on that, and we see the inner relationships, and so now we have the different failure modes. So every requirement has a particular failure mode or more than one failure mode. And so in one sense, that's one of the problems, because we can have multiple failure modes. We just cannot come up with these individual lists of failure modes, because the failure modes, in order to do the causal relationship, we now have to link the failure modes from one level to another. Go ahead, Chad.
So what we see here is actually in red, the failure modes. And then we'll also just say this, just to have you think outside the box. In this example, we purposely gave you 4. And you'll see that there's a thought that how goes to the left-hand side, and you ask the question why. Why does it fail? Well, because of this. Why does that fail? Because of this. Well, how does it fail? And you can go through one side with the how and why question. So here you go with the failure net, right. Greg.
Yes, and so really this is the failure net. Once we get all the failures, we can now get the cause and effect relationship. So the higher level failure modes eventually end up as effects of the focused. So I take a look, in order to build this, I take a look at my focused level, and I take a look at failure mode from there, and I say, all right, what is the effects of this particular failure mode? And then we go to the right and we say, when we're looking at how, what are the causes of this? So this is graphically what you would be doing if on the form, or what you're even doing in the current approach. You have the failure mode, and then you ask the effect, where in the current way we would be brainstorming under the new FMEA, because we have built the information about our higher level, we can just associate the higher level failure modes as effects to the focus failure modes. And same thing on causes. Causes are always due to the things that are inside the product, the subproduct, or the subcomponents in that. So I now, instead of brainstorming, in order to do that using subject matter knowledge, well, I still use subject matter knowledge, but now I have to make sure that I do have a component and I do have a failure mode of that component I could link up. So now this gives us our cause and effect relationship. Go ahead.
Greg, I want to make one point here about the difference in approaches. Never if it came up, it came up, but when we looked at one level, for example, the driver airbag, we focused only on the driver airbag, and we said, what is the effect? Yes, we did look at the next level up, but we also looked at, anything up. And then when we looked down, we were looking at the current design and coming up with the causes on the current design. In this methodology, the causes are always at a lower level element.
Yeah, as well as the effects being at the higher level, which this graphics kind of shows how the cascading down on that. And as you say, that is one sense a limitation, because some of the effects may be non-product related effects. As it turns out, you can still use it. What you do is you start introducing non-functional functions in order to be able to do that, things like cost or that sort of thing. As well as on the causes, if you have something that is a non-product cause, well, then you introduce a non-product product and put the same sort of thing in there. So there's ways of workaround on there. But if I was,
we'll definitely bring that in when we sort of look at the methodology to make sure there's a good hybrid, and we hope, of course, that the manual itself can address it. And in this example, Greg, it's a very good example to show how the cause of the brake system becomes the failure for the caliper failure, and the effect becomes the failure at the higher level. And it shows the cascading relationship between the higher level and the lower level. And in the next slide, also how that translates down to sort of manufacturing, from the piston assembly to the piston assembly manufacturing. Comments, Greg?
Yeah, it definitely, the whole thing is the flow down. As it turns out, the previous fourth edition did have showed how both the effects and the causes cascade up and down through these different layers. It did not utilize it in any kind of analysis as this, but it was used mainly to get people to start thinking that we do have flow downs and flow ups on there between the cause and effects.
So, Greg, what I'll do is I'll continue with the airbag example, where the function analysis are done, and then we go now to the table view, and you can actually type in the failure mode on the right-hand side, and then you can again drag and drop and update. Of course, is a drop down, because for the initiator, the failure modes are in a product family failure mode, and so you then have the driver airbag having two failure causes in the initiator and one effect in the front impact airbag system. Go ahead, Greg. So,
okay.
Fifth step.
Yeah, the fifth step is the risk analysis, which essentially is what are your current controls as you're doing it. So you need to have the current prevention controls, and prevention controls always focus on the causes, which would be the lower level. The detective controls could either be applied to the cause, which then be able to detect the cause, which is at the lower level, or it could be you're trying to detect the failure mode, which is the focused failure mode, which is at the focused level on there. And then you do the same, the logic of putting in the occurrence and the detection on that. All right, get the next slide.
We'll just continue with the case study where the initiator causes have been defined, and what we'll be doing is the risk analysis and the optimization can be done directly onto the cost branch, or as you'll see, it can also be done right to the form itself. So once we get to the important point here, that what we'd like to make is, till this point, there's this three-dimensional effect between the three levels. Once we get the failure analysis done, we can actually just go directly and fill out the form. In this case, we actually filled it out in the the element level of the relationship between the focal element, the lower level element. We actually did it on the lower level element, and it updated into the FEMA, but they could have come directly and actually updated the form. Greg, do you want to talk about the high, mediums, and lows? I know you'll talk about it some more. Maybe I'll just point out to them that it's not RPN. Now, I know Greg mentioned to me that there was a strong discussion in the 4th edition itself to see if we can do away the RPN, but many of you out there have been using what we call business rules in terms of high, low, and medium, and of course the idea is to focus on the highs and then the mediums. I'll just go on, Greg, and when you continue here.
All right, the severity is the same thing as the severity in the previously, is to take a look at all the different effects, and then the one that has the highest, and again, it's a ranking of 1 to 10. Go to the next slide. This is the new proposed table. The biggest change on this is the 9 and 10 are split. 10 is uniquely safety. It doesn't have with and without warning. As long as it affects safe operations, it's a 10. 9 is now is strictly with respect to regulation. So they kind of split this up because people were talking about which one is more stringent. The rest, as you see, is pretty much the same as it was before. The 4, 3, and 2 does not have any percentages, whereas the 4th edition, they did have percentages to define what is most, many, and some effect. 1 is, as before, no discernible effect. So the key thing in here is the split off of regulations from safety.
Greg, I think
also,
maybe, go ahead, Greg.
I was saying, notice also there is, and all of the different rankings, they have a blank line so that it says that individual companies can come up with their own terminology on what each of these rankings are. This actually is no different than it was in the past. Go ahead, Chad.
Yeah, Greg, I think one of the points, correct me if I'm wrong, if you have a 9 currently in the AIAG DFMEA, it'll get revised to a 10 in the new DFMEA. Am I right in saying that?
If it's safety related, the answer is yes. If the reason why you gave it a 9 was because of regulations, it would stay a 9.
Okay, great.
All right, Occurrence, the fourth edition made a big change in coming up with Occurrence and being, it was using the, essentially the first column, the product design units versus maturity to do it. The use of the fourth edition was always assuming that you were applying the preventive controls. Well, the new edition, they actually will have two additional columns on that, or really three additional columns. One is for the user to set up their own, which would be the expected occurrence, and then they do have two columns dealing with the experience based upon preventive controls. So they spell those out a little bit more deterministically than in the fourth edition. Go ahead. Okay, the detection is pretty much the same as it was in the fourth edition. The detection column, this was probably, from my standpoint, they don't really tell you what many, most, or high detection, low detection, very low detection on it. They don't actually specify that, whereas in the fourth edition, it was tied into what kind of testing you're doing, whether you're doing degradation testing, testing to failure, or go no-go testing. The overall description of the table does say you should look at timing. In the fourth edition, it actually had a division at up to 5 if you were before freeze, and after 5, 6, 7, 8, or after, and 9, 10, or if you were after design freeze and doing it. So it's advised, but it does not work indirectly to any of the rankings per se on the detection columns. All right, go ahead. Once we get that, we want to optimize. We have to decide whether or not further efforts are needed. This used to be done by looking primarily at severity. If it was a 9 or 10, you would always look at it. If it was after that, then you use the RPN or some other indexes that, if you wanted to, there were S times O or SOD and concatenation and so forth. The new edition now comes up with a series of tables, and the tables are indexed, again, 3 layers. In this case, the rows and columns are severity going vertically, occurrence horizontally, and this is for if you have a detection value of 7 to 10. And as Chad mentioned previously, we call these defining business rules of how you're going to do what you're going to do. So you see, if you have a detection value of 7 to 10, unless you have an occurrence that's 1, 2, or 3, you are pretty much, you are high level of risk, and therefore you need to take some action on it. If you have an occurrence value of 1, which has no discernible value, which brings in the whole question, is this really a failure mode? That is always low, so you always have that. Because it has the different detection, next slide, Chad, Chad, could you hit the slide?
Yeah, I think this is the next slide, Greg. So you are here.
No, it isn't. This is 7 and 10.
Okay. I'll go to the next one. Go ahead.
You're right.
Is this the one, or? Yeah.
Okay, yeah. Well, all right. Evidently, timing is bad. Anyway, you've got the 5 and that, and this is the 2 through 4. Notice that with the detection values at the low end, you have a lot more low-risk items and a lot less high-risk items. So we have that, and then finally the last table slide in there. Should have one more. This is one of the interesting things, and remember, this is a draft, so I assume this will be taken care of in the final release, is that if I have a detection value of 1, so if I have a detection value of 1, we still have high values or high risks, which are 8, 9, and 10. Now, as it turns out, there's this gap that says it's not defined, but I wouldn't worry about that. That'll probably be taken care of in final release. But it does have a whole lot of lows on there. And again, as all the other ones, if you have an occurrence value of or severity of 1, it's always low across the board. So they do have these different tables, and the tables are different for DFMEA and TFMEA for priorities on this. So you would, for each of your particular requirements, you come up with what is your action priority, whether it's low, medium, or high. All right.
Great. And one of our favorite slides to just question ourselves. Go ahead, Greg.
I'm having a timing problem because I don't have it yet.
This is the, I'll just go ahead. You know, one of the things we do, where interestingly we ask people, which one is much more, you know, which one would you work on? Would you work on the severity 10? Or would you work on the occurrence 10? Or would you work on the detection that's at 10? And it's interesting to know how decision making is done. Typically, we get a split. And lots of people say because it's a 10, we are going to work on it in terms of action priority. Some people say, and Greg has said this, hey, I know if it happens, it's going to fail because the occurrence is pretty high. So, you know, the one in the bottom. So anyway, it is something to make you think. With that, we're going to.
You may want to hit. You may want to hit the slide it there because I'm still having the action priority slide showing. Yeah. And I'm seeing that there is
here what the audience view is. Greg, the audience view that I'm seeing is at this slide that I'm at. So
okay, and I just got a little note that say my connection to go
to. I'm going to go ahead and just finish it up, and then we'll go on to the questions, Greg. So one of the changes you see is responsibility and targets, or the recommended actions, have been broken into preventive actions and detective actions between the current AIAG 4th edition and the new FMEA. What is the, so that's there. What else is new? Well, there's a status now. And actually, we didn't say it, but let me just say there's an action taken with a pointer to the evidence is also something new in the new AIAG VDA FMEA. All right. So let's just move on. We all know that preventative and detective actions and actually FMEA is new. It's live. And the IATF has requirements in there in, let me see if I can say the clauses off the top of my head, 8511, and then also in the problem-solving one, which I believe is 9.3, if I'm not mistaken. Maybe that's maybe I'm off by one number. Maybe 10.3, where you have to come back and update the FMEA. So, folks, this is the last slide before I go on to the summary question. So this, folks, is the new AIAG VDA FMEA 1st edition in draft. And, it would behoove all of us to take a good look at it, get the draft. You can't get it, but you can view it and then comment. And as we summarize it, I'll just say this here. One of the key changes, of course, is the idea of levels. But let me pause here. We have a number of questions from all of you, but let me give the rest of you time to, a minute or two to write down questions. I know it feels like a long time here. It's typically in these kinds of situations, seconds seem like minutes, but just want to give the people who want to ask questions a chance to write down questions. With that, let me summarize the what we have done this far. And as you know, the webinar goes on for another 20 minutes. And what we'll do in the next 20 minutes is take questions, and we'll finish with a panel discussion from our technical director of Intertech and from our QMS compliance manager from Flextronics. All right, so what is the summary? Well, number one, this document we're looking at is a draft stage. It is open for viewing at AIAG, also for commenting. The first release is planned for March 2018. And folks, I had a question, when do we have to start applying it? The thought was maybe end of the year, after the registrations, or maybe it'll be next year. But there's a lot to be done before that in terms of acceptance of this new FMEA. The third bullet, the new FMEA has adopted a 6-step process for both DFMEA and PFMEA. And Greg, I'm going to have you comment on this next bullet. I know I said DFMEA has been most profoundly affected because the relationship is between a focus element, the higher level element, and the lower level element. And Greg immediately said he thought it was a PFMEA. So as we were discussing it, right, Greg?
Yes, that is true. I thought. Go ahead.
Yeah. No, go ahead. Go ahead. Give your comments.
No, I was saying is that I definitely think that the PFMEA they tried to put the PFMEA approach, instead of using a different approach for PFMEA, they tried to stick the PFMEA into a design approach as opposed to a process approach. That's my comment.
Yeah, we'll explain that more in the next webinar. So the fifth bullet here, the cause of the failure in the DFMEA is always at the lower level element. It also assumes, here's the thing, the DFMEA team understands the higher level and the lower level. Of course, to really make it work well, customers and suppliers and sub-suppliers now sort of need to work together. And a comment from Greg, this approach requires a higher level of competency in the FEMA team or facilitator. And then the AIAG VDA FMEA handbook recommends the use of a FMEA software for complex systems. And of course, you know, for simpler systems, maybe we can get away with using a flat file. And this FEMA methodology, when released, will not be applicable until after the IATF 16949 deadline. And with that, we're going to take questions. So before we take questions, I'll just do a couple of little, information on books that I have written. One on integrated management systems, a how to audit ISO 9001 2015, IATF 16949 courses available from Omnex, 26262 and Automotive Spice. Very importantly, we'd like to brag a little bit of being able to know IATF 26262 and Automotive Spice. We do have classes for the new DFMEA and the new PFMEA. Courses in Europe using the VDA approach or the AIAG approach. Everything you're seeing here is really VDA. And then some upcoming open enrollment courses, public training courses in Europe. And of course, the IATF 16949, sorry about that, the new FMEA, core tools, and so on. So public training in North America, CQIs, VDA 6.3, and so on. All right, with that, what we'll do now is I'll take on the first question. I think we actually answered it, but Greg, I'll give it to you. Can you give me an example of a focal element and a higher level element and a lower level element?
Well, the example we used during the webinar was the focal element was the frontal collision airbag system. The higher level would be the vehicle itself, and the lower level would be the different elements within that airbag system, like the ECU or the sensors or the physically the airbag and initiator complex themselves. The other example was that was given in the webinar was the throttle positioner system, which is itself a lower level from the entire electronic acceleration system, but it itself has different components, and each of those are different subsystems, and each of those subsystems have different components. So there's a range of values. You don't have to always go out to the car in order to get the 3 levels, but you need, in order to do the new FMEA, you need 3 levels. The level you're concerned about, the focus level, the level above it, where it's going to be used, and the level below it, what are the components, parts, subsystems that make it up.
So Greg, I'll also say this, when you go to the structure analysis, you can easily understand the higher and the lower. Let's go to the second question. Where can I get the draft of the new FMEA? You can get that from the AIAG. I think you actually go and you buy it, but they won't charge you anything for it. Yeah, go ahead, Greg. You did it. Somebody did it for me. Yeah, go ahead.
Yes. You have to. You go to their store, and you put down that you wanted the AIAG VDA FMEA, and you go through the buying process, but the price is 0, and so it just goes straight through. You do not get any physical copy. What you do is get an e-document access, and so you still have to go through AIAG every time you want to read it, but it is one of those e-documents. If you go through that process, you are expected to, if you will, pay for it by providing comments.
So let me continue on. Folks, some questions don't make as much sense to me, so I'm going, just because there's a ton of questions, I'm going to skip some of them. If it is not required for IATF 16949, does it mean we have 3 years to implement it? Folks, that kind of a deadline has not been given, so we're going to have to wait and find out, how is it going to be applied. Does this new revision to the FEMA manual mean, it's another question by the way, does the new revision mean that the FEMAs for individual components will be replaced with the FEMA for the entire assembly? And the answer is no. You'll have to still do a FEMA for the individual components, and you will have a higher level element, and there'll be a lower level element that at the component level, what we have seen is the characteristics being taken as a lower level element even in the design. I'll just stop there for a second. I'll just skip that for a second, but the answer is you will have to do one for individual components also. Let me go on to a next question. Greg, I'm going to take them all real fast. If you want to give an answer, I'll turn. Yeah. Is your primary focus, and if your primary focus on product is at the component level, not the system level, how will this be handled? It's the same question. You take that on if you want to say it any differently, Greg.
No, go ahead.
No, I gave the answer earlier. You will need to do it, and there's an approach to it, and our training will show how to do it at a component level. Next question. Yeah. Does Omnex recommend using, folks, we showed you EWQMS, so they're asking EWQMS software, do we recommend it? We're not going to recommend anything, folks. There's, I'm sure there'll be tools out there, and you can pick whatever suits you. You know, and some of you might be able to still work with Excel, maybe. Does this new method work well for non-manufacturing PFMEAs, such as order entry? I'd like to say something on that, but I'll give it to Greg. Greg, I've thought about this. You know, go ahead.
I would say we really should defer that to the next seminar or next webinar where we're talking about the PFMEA.
That's right.
Because it does have unique considerations.
Yes, yes, you're absolutely right. So when we do the next webinar, we'll talk about that and we'll take that question on. I'm just going to skip a couple of questions. Okay. What happens if you supply a material to a tier 3 supplier? Do you have your system be, so how, you know, I have not thought about this one, Greg. There is a DFMEA for material, you know, for like a bulk supplier. Have you had a chance to think about that?
No, not really. I would assume it's, if you're obligated to do an FMEA, a DFMEA for a third-tier supplier, then you would still be obligated to do a DFMEA even using the new form, and that you just have to, when you're doing it, you still have to come up with the 3 levels. You may have to come up with a surrogate level if you don't really say, I don't really have any components of this raw material. I'm just doing the ore. Well, where is the ore? What is the components of the ore? Well, you can say that those are the natural occurring metals that are going to be in there. So you could still go ahead and do it. If you did the DFMEA before, you can do a DFMEA now.
Okay. All right. Another question. If failure causes are always assigned to lower levels, how do you address failures due to the current level? I'll say it like that. They didn't exactly say that. For example, a failure occurs not because a component fails, because the wrong component was designed in at the level that you're looking at. Greg, do you want to take that on?
Well, again, you can when you're.
But let's do this. Not what we can, Greg. From the current methodology, how does that work? Let's do that, if you don't mind.
In current methodology, you just identify that particular cause. When you're saying is that I designed it wrong, well, that's the whole thing on all the FMEA design FMEAs, is that what in a design process would I do? But when we say that I've designed the wrong component, well, what about that component that is wrong, if you will? So I don't know whether there's just a generic answer for that. I think you still have to go in and do the.
In our third webinar, folks, we'll take on this, and we'll talk a little bit about will let's see, if everything in the system, for the system, let's say the focus element, if the causes are the lower level element, will the focus level elements failures all come up when you look at the higher level element? It's something to think about, and we'll answer that in the third webinar, which will be a higher level webinar, and hopefully you'll have some chance to digest this thinking. So, Greg, maybe we have questions for one more, and we have 4 pages of questions. So let me go maybe to the What is the guidance on L, M, and H items? Must all H be addressed?
Eventually, yes. I mean, those are high. You have to then use, obviously, you say, I've got all these H's, which one do I work on first? That's the reason why the team gets paid the big bucks. They have to take a look at other things. It could be severity. You could calculate an RPN and then say, this is the order in which I'm going to be taking them. The table just says that when you have an H, that's a high risk and you need to do something eventually. It's the order in which you pick those H's, that's up to the team themselves.
So, folks, I know we lost Greg there for just a second, but Greg said, you know, of course, if you have H's, you'll have to do it as per your resource requirements, the resources available. With that, Greg, what we'll do is introduce our panel members. We have George Correa, who is the Technical Director of Americas from Intertech, and Rod Gray, who is the QMS Compliance Manager with Flextronics. Rod and George, welcome.
Yeah, thank you. Thank you.
So, folks, the first question for both of you, one by one, we'll ask Rod first. What are your initial thoughts about the new FMEA? What did you think?
Well, I think, and again, going through this first webinar and broken up into three, I think is going to be excellent for the audience. But the three-dimensional approach and the structured approach that has been now emphasized with a greater focus, and I know that Greg had said that the PFEMA is taking the same approach as the DFEMA, but from a design point of view, I think that this is going to be a big benefit once we all understand it. And I think there's a lot of, there's going to be a high degree of need for better training of folks or retraining of folks to the new system, which I know Omnex provides very well for all of us.
Thank you, Rod. Let's ask George what is his initial thoughts. And George and we all worked together many years ago. And welcome, George.
No, thank you, Chad. You know, it's always a pleasure. I mean, I've known you for many years, so certainly good to see this your webinar and all this excellent insight into what this new edition of the FMEA is going to look like. I mean, I agree with Rod. I think looking at this, I looked at the article, and also after looking at this presentation, I think this is a definitely a step in the right direction for many reasons. Again, from a certification body standpoint, such as Intertech, and even for the organizations that are going to be using the FMEA approach. I mean, for starters, this is giving us with some standardization. A long time complaint in the automotive industry has been all these different customer specific requirements. So VDA has their FMEA format and AIG has theirs, and everybody else has their format. So certainly this is a great step into standardizing, and not only that, but also getting learning from best practices from the different applications, the VDA method in AIG, taking these and merging them into a single document that includes these best practices. Certainly, like Rod is saying, it's going to require additional training, but I see this also as an opportunity. I mean, if I look today at the application, at the design FMEA and process FMEA, unfortunately, in many cases, it leaves a lot to be desired. Even some companies do a great job applying the FMEA methodology, and some it seems like it's more of an afterthought, and still there's not a good understanding in many cases, or it's just done basically because of standard requirements. So I think that with this different method, and by looking at the linkages, within the different tiers of the system, subsystem level, I think that will provide a better understanding to different organizations and manufacturers of the real benefit and advantages of using this method. And well, also because again, this is also taking from the different best practices. It's also another opportunity to to raise the bar and continue, that trend of improving, performance and quality, just like the article that's posted on the Omnex website, shows. So, definitely, I'm personally, very happy to see, these changes, and something that will be, I think, of great benefit to any organization applying it.
So, George, I think it seems like we're all unanimous in saying this is a move in the right direction. And I had thought of, let me just ask Rod, and then I'll come back to you. I think you actually may have said this already, but I'll just have you say it anyway. But Rod, what do you think is the biggest benefit and the biggest drawback, if there is any?
Well, I think that the benefit is it's a restart, so it's an opportunity for companies to take the fresh look. I see both in the IATF 16949 as well as here the greater emphasis on risk, and I think that that's something that all organizations going into the autonomous vehicles need to focus on. I like the AP replacement or optional replacement for the RPN plus the high, medium, low. I think folks need to get their minds wrapped around that, but I think that that is going to be a benefit as well. I think on the downside, there's a lot here, and people are already maxed out and taxed from the 415 to 800 shell requirements of IATF, depending on how you count the requirements. But it's something that has to be done, again, going into the autonomous world, and I think that executives need to have a better understanding of this as well. I just thought of that. So, to get their engagement coming down through, the one aspect that, and I put it into some of my comments back to you for AIAG, but ownership, I stress who owns the process or who owns this document. And one of the things I see missing is a real solid definition of who owns the DFMEA. We talk about the team, the facilitators, subject matter experts. One person needs to own it, and it's not always the quality engineer at the end of the line doing it on his own at the end of the day. So I think stressing that too in the coming out of the draft, and maybe if there's an opportunity to add language, defining the process owners and having further discussion about that, as well as in training. This isn't just a quality role document. Roles, responsibilities, authority is defined in IATF, needs to be defined very, very succinctly here too. I see that missing, but it could be fixed. One other thing.
Yeah, go ahead, Rod.
I see hidden liabilities. We work very closely with our legal counsel. We've had legal counsel from all around the world come in and talk to us about our QMS and engage people in a very new way in regulatory requirements. I see, as I read down through the document, the new document, I see some hidden liabilities that, again, maybe from a training and from an accountability point of view, need to be brought up so that we don't get ourselves into trouble legally down the road when there's recalls or some kind of tragedy that happens, because this is a record of how well we've structured our thought process around risks.
Thank you very much, Rod. Of course, I would have liked to have comment on it, but for time purposes, let me go and get George's take on the biggest benefit and biggest drawback.
Yeah, thanks, and I'll try to be as brief as possible. I agree. My thoughts are pretty much in line with with Rod's. Definitely, I think the biggest benefit is that, of course, this takes a whole fresh new look from a risk standpoint, which is really one of the key benefits you're getting. You're giving a fresh new look to the potential and actual risks related to any system or subsystem in the automotive world, and especially today where vehicles are evolving, as technology is evolving, and your vehicles year after year become more dependent on this technology. Well, that also carries different and greater risks as well. Actually, even of course, we have now the autonomous vehicles, and there was actually, I don't know if any of you read a recent interview with Bob Lutz, the former GM executive, where he basically talks that in 20 years most people are not going to even own their own vehicle because it's all going to be shared and autonomous. So it's pretty interesting. But I guess the reason I mentioned that is precisely because as the technological content in these vehicles becomes more and more, definitely the risks are going to be greater, and tools, like this approach, to the FMEA are going to be even more and more critical to prevent those risks and and reduce the exposure to liabilities, like Rod is mentioning. Yeah, of course, the drawback, is also that there's you have all the potential legal liabilities, which I think part of what that will result is that a lot of these documents are going to become more and more subject to confidentiality restrictions of some sort. But in the end, I think the negative, anything negative is more. I guess the positives outweigh the negatives. Like Rod is saying, yeah, sure, everyone is overburdened by all these changes and a lot of work. But also, I think that this methodology is going to push everybody to have these documents be more in collaboration, more team-based, as currently, where in theory they're supposed to be team-based, but in reality a lot of times get assigned to a single person. But looking at this presentation, definitely getting this approach implemented by a single person is going to be very difficult to do, because it's going to require collaboration not only within the organization but also from suppliers and also the customers. And again, if we're talking about the lower levels like tier 2s and tier 3s, well, they're going to need to have even more interactions with their customers at the higher levels, whether it's the tier 1s or even the OEMs.
Great. So George and Rod, thank you so much for your great insights. And I just will sum it up with a comment here, which is I think it's a benefit and a drawback, if you want to say so, is that as we work with teams at Omnex, we find, Rod and George, that the company that we're working with doesn't really know much about the product that it goes into, not enough, or enough about the suppliers. So, benefit and hindrance is how to bring the supply chain working together. So I thought I would say that because we won't get a chance to mention it again when we do the PFMEA. With that, let me say thank you to Mr. Greg Gruska. If you have known Greg, he's just done a tremendous amount of work helping the automotive industry. And somebody I can say worked with Dr. Deming. People like that are becoming very far and few between. Mr. Jorge Correa with Intertech, and Rod Gray from Flextronics. Folks, thank you very much, and thank you from myself, Chad Keimel with Omnex. Thank you all.
Thank you.
Bye-bye now.
Thank you. Bye.